All right, so the first example we're going to look at is for type 1. So we're going to have some fixed value for our lower bound, and we're going to go to infinity for our upper bound. So let's start with an example that works, that will give us like a finite value. So I'm going to go from 1 to infinity of 1 over x cubed dx. Okay, so let's think about what this function looks like maybe to begin with, at least on the domain that we're interested in from 1 to infinity. This function is going to, do this. And so we have a chance here, right, of actually getting a finite value because, 1's here and then infinity is out here. So the only question is this thing getting small enough, fast enough as we go to positive infinity in order for us to get an actual finite value for this integral? So let's see. Let's use this definition and see what we get. So remember, let's recall the definition. It's we're going to take the limit as b goes to infinity, where b is now going to take the place of our upper bound, f of x dx. Okay, so let's see how this goes. All right, so we're going to replace our upper bound with b, and we're going to let this upper bound go to infinity. Okay, remember, 1 over x cubed is the same as x to the negative 3, and so we can just apply the power rule here. So what is the power rule? We're going to add 1 to get negative 2, and then we're going to divide by this, so it's going to be 1 over negative 2. And then our bounds are 1 and b is just holding the place for infinity. And so in the end, we're just going to plug b in like we would any value, but then at the end, we'll take the limit as that value goes to infinity. Okay. All right. So I'm going to, let's remember some properties of limits. You can actually take this negative 1/2 all the way out to the front. Right? And so really all we're dealing with is this 1 over x squared. And we're going from 1 to b. All right. So negative 1/2. The limit as b goes to infinity. And now we're going to plug in b and 1. And you don't have to take the negative 1/2 out if you like leaving it in or it makes more sense to you. But just make sure you know what we're talking about here. It's 1 over x squared. And so let's write it down. That's okay. So if I plug b in, I get 1 over b squared. And if I plug 1 in, I get 1 over 1 squared. Okay. So notice in this case, we're going to get an actual answer, a number. And in this case, we're going to have the variable b still here, but we're going to take the limit as b goes to infinity. So then there's the question, what is the limit? So we know what this is. It's minus 1. But what is the limit as b goes to infinity of 1 over b squared? Yeah, and so let's think about this too, because the limit as b goes to infinity of this, so this is equal to 1, it has no b in it, and so b going to infinity doesn't change the value of this term. It remains 1. And so if there are no b's in it, if it's a constant, then the constant remains after the limit's taken. But in this term, we do have a b. And so we can think about this a couple ways. Might be good to recall a few things about limits at infinity. So let's think about what happens as b gets very large here, right? So what is this whole thing tending to do as b gets large? So, if you plug in 1, you're going to have 1 over 1 squared, which is 1. If we plug in 10, we have 1 over 10 squared, which is 100, so it's 1 over 100. If we plug in like a billion, it's going to be 1 over a billion squared. And so these numbers are getting smaller and smaller, and in fact, they're approaching zero. So this is something you would have covered in calculus 1, right? And so if we have the bottom of a fraction growing faster than the top of the fraction at infinity, then the limit of that will be 0. If the top of the fraction is growing faster than the bottom, then the limit's going to be infinity. And if they're growing at sort of the same rate, it's going to be some other finite value. But most of the things we're going to look at, we're either going to be in the case where okay, we had a slight interruption. Yeah, so in most cases we're going to have either something obviously going to 0 because the bottom of the fraction is growing very large and the top is constant, or something obviously going to infinity because the top is changing and the bottom is constant. Okay, so anyway, so we get down to something very simple in the end, right? So it's just 0 minus 1 times negative 1/2. So this is negative 1/2 times negative 1, which is positive 1/2. And so what does that mean? It means that the area trapped under the curve here between 1 and, we're considering this going all the way out to infinity, is only 1/2, right? So this area, even though it's infinitely wide, is finite.